let's take a look at number 2 on that reference sheet. So basically, I want you to be able to solve fundamental equations which are in such a form when we have sine theta equals to a number. Right? And I want you to find all possible angle theta. And there will be infinite many. Right? And that's probably what bothers people. So let's do that together. All right, so that's number 2. All right, so our goal is to get sine theta equals 1/2, right? So what will be the angle theta? So we'll use the unit circle, and I'll plot a point P. Let me remind you, the horizontal coordinate of the point P is cosine theta, and a vertical coordinate is sine theta. Okay. And by theta, it's the angle, right, associated with a point P, or if you think that it's just the angle in between the horizontal axis and the radius OP. Now, just by staring at this equation, sine theta is 1/2. Would you be able to guess what kind of angle you need to get sine to be 1/2 just by looking at the chart on the board? What angle will get you sine to be 1/2? 30 degree, right? So let's go ahead and label it 30 degree. But unfortunately, this is not the only angle you should find. See, sine theta is the y coordinate, and it needs to be positive 1/2. Would there be another point which has the same exact y coordinate as the P? It'll be somewhere on the unit circle. Where would it be? I want another point that has the same exact y coordinate as the P. Could it be in somewhere down below? The y has to be positive 1/2, right? So the lower portion of the circle has negative y's, right? The negative y coordinates. You see that it has to be on the left-hand side of the y, right, in the second quadrant. And to correctly plot that point, I'll draw a horizontal line, and I'll intersect the circle, right, at the point Q. So you see that it's pretty much reflecting the point P about the y-axis, you get the Q, right? Again, does the Q has the same exact y coordinate as the P? Yes. Now, what about that small angle on the opposite side of the angle 30 where I figured out? How much is that? Well, it better be 30, right? Okay, so now it's the fun part. You can read off the angle to that equation. So the first angle will be 30 degree, right? Now, what's the other angle associated with the point Q? And I want you to tell me in a standard position, which means that the angle always starts from positive x, going all the way to the point Q. How big do you think that angle has to be? It's 180 less 30, which is 150, right? Okay, so but there are only 2 angles, right? How come there are infinite many? So, but now, yeah, so now it kind of makes sense, right? Okay, so now here's the cool way to cook up the solutions that has infinite many angles in it. Base of the 30 and 150. What if I said, hey, the P will go around and come back to the same point? So you're not looking at 30 degree, you're looking at what? 30 plus 360, right? I can go another round, or I can keep adding a multiple 360, right? Or what if I go in the opposite direction, right? So be subtracting, right, multiple 360. So that means all I have to do is to write the solution in such a format, plus n times 360. And I'll do that for 150 as well. You might say, what is n? N is an integer that takes the value 0, plus or minus 1, plus or minus 2, plus or minus 3 if you want, dot, dot, dot. Now let's see, what does 0 of n represents? To take n for 0, right? You're adding nothing to 30 or 150. Those are the two fundamentals we just found. What if n is equal to 1? You're adding 360 to both angles, right? What if n is equal to 2? Adding 2 times 360. What if n is negative 1? You are subtracting 360 from angles. But all that many angles, they differ by a multiple 360, are called coterminal angles, right? They're all the same. And therefore, you must get all possible angles, but all the angles are based on 30 and 150. All it takes to get all infinite many angles is just put that thing down, right? To let me know, there could be, that many angles, right? Again, if you're ever confused about n, it's just integer. Now, what about number 3? Guys, take a look. Number 3. All right. So now we want, instead of sine theta equals 1/2, right? So we will do sine theta equals negative 1/2. Okay. Oh, let's do the different color. Right. So it'll be exactly matched. So number 3, right? So we're doing sine theta equals negative 1/2. So now the sine theta is the y coordinate of the point P. Now I want it to be negative 1/2 instead of positive 1/2. Where should the point P be located on the circle? So it'll be down there, right? And the way to draw it, make sure that you're also getting pretty much like the P reflected off from the x-axis, right? And guess what that angle have to be right here? Take a guess. If you're going up by 30, you get the y coordinate to be positive 1/2. So now if you're going down to get negative 1/2, what will be that angle? It will be still 30 degrees, right? And guess what the Q will have to be? Will it be just, again, reflect off the y-axis? Right on the other side, right? And the angle on the opposite side better be 30 as well, right? So far, so good? Well, again, the fun part is, let's read off the two angles associated with the point P and point Q, but the green version. All right. Can anyone tell me the angle that starts from here going all around to the Q? How much that angle is in degrees? So what's the question? I said, how would you find out the angle associated with the point Q, which is now down below? In a standard position, I mean, you have to start from the positive x, going in the counterclockwise direction, going all the way to the point Q. How big is that angle? And I think some say 210, right? Because you are now looking at 30 more than 180. Yes. So it'll be 210. Now, what about the angle associated with the point P? You sure can. It's 330 because 30 less than, 360, right? To make them fancier, adding the multiple 360. And you're done. Not anymore because sine 30 is not going to be negative. Because you want a negative 1/2. And that's why I wanted to look at those two questions at the same time to see the difference, right? Once you figure out the easy version, then play with the negative one, right? So again, before I move on, any questions so far? Yes, Alana? You could, and you're gonna, so if you use the calculator, you're gonna get only one of the angles, right? So let's say if you type in inverse sine of 1/2, you're gonna get 30. So however you do, you're gonna have to figure out 150, right? Now if you do negative 1/2, I think that you're gonna get negative 1/2. Let me see. It will probably tell you negative 30, right? Try it. That's in radians. Yeah. So negative 30. Okay. Oh, here's the cool thing. If you want to like cheat a little bit, if you don't like the big angles associated with the P and Q down below, you know what? For the 210, I could have write negative 150 plus n times 360. Now for 330, it's even better. I can do negative 30 plus n times 360. Now, why am I able to do that? Instead of going in a standard direction, right, the counterclockwise direction, what if I just go down by 30? But you have to put negative 30. And if you go all the way here in the clockwise direction, you get negative 150. But do you see that 210 and negative 150, they are coterminal because they're off by 360. The same thing here. 330, negative 30 are off by 360. If you want, if you want to know like which version do you put, whichever version you like. If you're like me, I like positive angles, I'll go with the big ones, right? If you want to cheat a little bit with the negative angles, negative 150, negative 30, right? I think that's a pretty smart, strategy, right? Mm-hmm. Yeah, half the credit because you have to tell me negative 150 or, you need to tell me two angles. For most of the equation, they have two angles plus the m part, right? One of my students in the first period asked, I get this, why do I have to show the unit circle? Do I have to put down that much work? The answer is no. If you're able to get me the right answers with the n, right? I mean, why would I crazy about, the work? And there's, I get this. Well, make sure you get the right angle, right? The correct one. If you think that you get it, but somehow the angle is wrong, right? So there's a problem. But the goal for me to do these in some sort of like a repetitive way is to make sure that you can see the angle almost instantly without doing too much work. But now later on, maybe Friday, you'll see that how would you write those complicated equations involving sine and cosine tangent into those easy versions? Because you know that once you get there, the answer is almost right there, right? So now let's do a few more so you get more confidence in this kind of a method. The one we could look at is, how about number 6? All right, so what we're looking for is sine theta will be radical 3 over 2. Okay. So now if the P here has cosine theta for the X, sine theta for the Y, right? This is what I mean by angle theta. how much you think will be the theta, such that sine theta is radical 3/2? Yeah, look up the chart. It will be 60 degrees, right? And sine theta is y. And I need another point that has the same y as the p. So it better be somewhere over here, right? The same exact y. So I reflect the p of the y-axis. And the q is going to have an angle on the opposite side, right? Which is going to be 60, right? And now, you guys tell me what will be the two fundamental angles. The one associated with the p, Max? 60 and 120, right? The one that goes all the way to q, right, is 180 minus 60. Yes, that's 120. And don't forget, add the multiple of 360. Okay, that's it, right? It didn't really take us, more than a couple minutes, right, to get everything done perfectly. And it could be even faster once you're able to figure that out on the entire sheet. Okay. And you're now going to be looking at number 7. All right, so now we're doing sine theta equals negative radical 3/2. So now you guys tell me, where should I plot the point P associated with the angle theta such that sine theta is negative radical 3/2? Okay, it will be somewhere down here, right? And that angle must be 60. And also the point on the other side, right? That's Q. And also you have a 60 again, right? Now, the hard part is, how do you put angle theta in a standard, position? What will be the first one? Let's say the one associated with the P or Q, whichever you like. Go ahead, Max. Okay, so 300, that's the one associated with the P, plus n times 360, yes. What's the other one? 240, thank you. 240, so basically adding 60 to 180, right? All right. Now, if you want to cheat a little bit with the negative angles, this is the same thing as negative 60 plus n times 360, right? And this guy is negative 120 plus n times 360, right? Yeah, let me pause. If you have any questions. Yeah. Cool. All right, so now let's do how about let's try some cosine, right? Just to see how it goes. Cosine and sine should be very similar, but it is because they're so similar. Sometimes you might end up getting something wrong since you're thinking about sine, didn't realize that you have to work out the cosine, right? So let me ask you to look into number 11. All right, so we want cosine theta to be 1/2, right? And again, the P has cosine theta to be its x coordinate. Sine theta is its y coordinate. But now all I care is its x coordinate, right? So the x coordinate, which is cosine theta, is 1/2, right? So it will be in the first quadrant. So what do you think will be this angle right there, such that cosine theta will be 1/2? It will be 60. There you go, right? Now, here's the hard part. Where is the Q? That gets you another angle so that cosine theta is also 1/2. Next. Okay, quadrant 4. So you reflect in the P by the x-axis to find a Q, right? And you can get that angle symmetrically down below, which is also 60 degrees. And let's read off the angle theta, right? So, well, obviously, I don't want to embarrass you anymore. This is so easy. So 60 plus n times 360 times 360. Now, or let's be a bit smart. Negative 60, how about that? Plus n times 360. And again, you can remind your reader, n is 0, plus or minus 1, plus or minus 2, dot, dot, dot. But if you do want to have the positive angle, you're going to go all around, coming back, right? So that will be 300, right? Instead of a negative 60. But, either way, you're fine. Sure. You're fine. You're fine. Until the problem that demands the angle has to be in a certain region, but that's what we're going to find out on Friday. We'll play with the n to get yourself those angles. But think about this. This is like you're listing all possible solutions. And some of the questions ask you to get them exactly the kind of solutions you want. But you have everything, right? You can always, screen through those solutions and get what they want, right? So now let's look into number 12. Right, 12 want cosine theta to be negative 1/2, right? Okay, so now remember, cosine theta is the x coordinate. So now I want the x to be negative 1/2. So I have to be on the other side of the y-axis, right? So here's the p, right? And just, because the symmetry, this has to be 60 degree, right? And also you reflect off the p, right? So you get, again, the angle down below, which is also 60, right? And again, let's read off the angle theta, right? I believe that the first angle is going to go from here to the p, right? So it'll be 120 degree plus n times 360 degree, right? Or you can do 240 plus, plus n times 360, or if you like, negative 120 plus n times 360 degree. Okay? Everything okay so far? All right. Now, your turn. I'll give you a few minutes, let's say maybe 2 or 3 minutes. I want to know all the angles for 15 and the 16. All right, so on that reference sheet, number 15 and 16. Go ahead. If you can get the right answer, however you want to do it. Yeah. But need all the angles using that n notation. 15 and 16. you finish, just look up so I know that I can move on. All right, take a look. Any questions? Okay. Yes, go ahead. Mm-hmm. That's the same. Or see that we have, yeah, so we have the negative 30 from, where is it? Okay, see that? Because negative 30 and 330 are exactly 360 off, right? So they're coterminal. So if you like to take negative 30, that's fine. Now, you guys ready for the tangent? Are you? Go ahead. Now, I think that you're probably gonna like tangent even better. Not always, but in this case, it turns out that tangents are easier than you thought. All right, so let's take a look at on the other page. Let's say number 2. All right, so number 2, tangent theta is radical 3/3. All right, if you're wondering, hey, where's the unit circle? Because you don't need it anymore. And that's how easy to work with tangent. So the first thing you definitely want to do is to either guess what the theta is or look up the chart, right? Or use the calculator. So what do you think will have to be? What do you think will be the initial guess for theta? 30 degree. Okay, yeah. So it's the same thing. All right. So now if you wonder, could there be another angle like we did, with the sine and cosine, right? Always finding the 2 angles. No, that's why I don't need the unit circle. But would there be still infinite many solutions? Yes. That means you have one solution to start to cook up the infinite many solutions. But how would you do that? Well, the trick is to add multiple of 180. Because the period of tangent is 180, where the sine and cosine are 360. Yeah. And now n, guess what the n is? 0, plus or minus 1, plus or minus 2, dot, 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 right? It's the same as before. And that's it. Yes, so if there's no work you can show me, right? If you know it, you know it, right? That's the goal, because it meant to be like that. And now, do you see that it was possible for us back then to work out everything without a calculator? Because they're only going to give us problem about the special angles, but they'll make it tricky enough so that you have to go through the reasoning, but we don't have too much time to figure it out in a test. We have to just get quick, right? And just make it like a muscle memory kind of thing. Okay, so now let's take a look at number 3. And I'll put it together with number 2 because you will learn, a lot by comparing these two examples. So now let's say the angle such that tangent theta will be negative radical 3/3. Guess what the angle has to be? Unfortunately, you don't have any negative radical 3/3 on the chart, right? Alexia? 150. Okay, I'll take that. Yes. Max, do you have a different one? Okay. Anyone else? Let me see. One. I think not 210. All right, so I'll say it's negative 30 plus n times 180. But that's why I said 150 is correct. Because 150 and negative 30 are exactly, 180 apart, right? Now, am I just me? I like to remember negative 30. Why? If the number is negative, the angle is negative. You see that? If you see, oh, what is negative radical 3/3? There's nothing, but I do see radical 3/3 here, right? The angle is 30. Well, guess what? If it's negative, you take the negative 30. But, if you like to have the positive angle, just add 180 to it. You're going to get 150, right? All right, so now, why don't you try it? Let's say 6 and 7. Oh. Yeah. I guess that that number does have some meaning. Anyway, so you guys go ahead and try the last two problems for the tangent. All right, so tangent theta is radical 3 over, just radical 3, right? Or tangent theta is negative radical 3. All right, I'll leave the screen like that. Yeah. Say again. So yeah, and I want you to start with those two angles, but only at n times 180 to them.
Yeah, that's what I did to get this one.
Right, but then if you only put these two, that means you're missing a whole lot of more, right? Make it as general. Yeah, you need to keep the n there, unless we do something on Friday. You'll realize that you have to fix the n, but that will be a much easier job, right? But you need to get that n first to have all the possibility there. Okay? All right, so I guess you guys ready for the answer, right? It's plus or minus 60, right? But positive 60 for radical 3, negative 60 for negative radical 3. You add multiple 180, right? Wow. No, we have a few more, right? So, you know what? I would like to do a little bit more, if you don't mind. Please don't mind. Because I do want to have the lesson recorded with as much stuff in it, in case you guys want to refer to it, or my 1-2 p.m. will refer to that, right? But I'm gonna go over these things anyway on Friday. But yeah, let's think about what about number 1. All right, so well, let's draw the unit circle. So where should it be the point P? Max, you want to let us know? Tell us. But you have to tell me why the angle has to be 0 or 180 degrees to start with.
This direction, and if the y is at 0, then it's at 0.
So, thank you. So, all right. First off, remind yourself, is sine theta the horizontal or the vertical coordinate? Sine theta is the y. It's the vertical coordinate, right? So you want points whose vertical coordinates must be 0. What are the 2 points? It's either here or there, right? What is the angle associated with a P? 0 degree. What's the angle associated with a Q? 180 degree, right? Not the same, 180, right? Therefore, it's, all right, so let me put this down. So 0, right, or 180 plus, you know what you have to add it to, right? Now, if I move over to number 10, guys, what do you think the angle such that cosine theta will be 0? Wow. I'm impressed. Right? P is here, Q is there, right? Because you want the x coordinate to be 0, right? That's the 90, 270, right? Plus multiple of 360, right? All right, so now you guys do number 8 and 9, 17 and 18. Number 8 and 9, 17 and 18. Once you're done, you're good to go. Uh, 8 and 9, 17 and 18 on the first page. Eight and 9, 17, 18. Sure. So in general, any point on the unit circles can have cosine theta as the x, sine theta as the y. Okay. Should be good enough. You done? Give it a minute. Now, when I was in college, there was this guy reviewing for the final exam for the calculus class, and there's a lot of integrals I have to do by hand. And the guy spent a couple of nights, just doing integrals over integrals. And there's one night, it was like maybe 11 p.m., right? He stepped outside to the hallway, because we have a dorm, right? And he's yelling that I'm the king of integrals. Yeah, that wasn't me. Not me. Not me. Seriously, not me. So I wasn't like that. You know, because you know it's not normal for you know a lot of Asian people like to step outside, yell out, you know, to show off, you know, how good they are. It's just our culture, right? All right, so now I'm gonna let you see the answer for those two. I'm sure that you got them already, right? Now, there's only one possibility for sine to be 1, which is at 90, and 270 if sine is -1. Yeah. Instead of 270, you can go with -90. Now, cosine will be 1 when angle is 0, and 180 when it's -1. All right. But yeah, there you go. So now, if there happen to be any entries that are still blank on the sheet, you guys complete that before you come to me on Friday. All right. This one. No. Hey, you know what's better than that? Because you guys can be king and queens of trig.